Good morning, good evening, wherever you are around the world. It's one of the most difficult challenges in today's world is being consistent. And this is the eighth or the ninth session that we are doing. And I'm really, really proud that we are being consistent and we are able to talk about varied range of topics around technology. And over the last few weeks, we have been talking about different kinds of architectures. This week, we would be talking about an important trend. I don't know how frequently it is used, how far it is being used in the enterprises. We'll find that out today. We'll be talking about event driven architectures. And to talk about that, we have Shiva and Koushik. Glad to have you guys here.
Thanks for having us, Ranga.
Thanks, Ranga.
Okay.
It's an interesting topic to talk about.
Absolutely. I'm sure. Like I'm not an expert at event-driven architectures. Let me be frank about it. So I would love to hear your opinions on where you see event-driven architectures. We'll probably discuss it at much more minute level. I would say we would start with discussing what is event-driven architectures, maybe go to the fundamentals, what are the enablers for it, and also look at what are the best practices with respect to that. What are the right use cases for event-driven architectures? One of the things I would want to tell the viewers is if there are specific topics you would want to have us talk about, like event-driven architectures or maybe reactive programming or things like that, if there are specific topics you'd want us to talk about, do post them in the comments so that it gives us feedback, and also it gives us opportunities to look at your ideas and maybe talk about them in the near future. Let's get started with event-driven architectures. Shiva, let's get started. What is event-driven architectures? How is it really different from other things we have been doing?
Yeah. So when we build any distributed system, one of the core concern that we need to take care of is fault tolerance. So when we are building a distributed system, we should make an assumption that at any point of time, one of the component may go down. So we need to design our architecture and our technical concerns in such a way that it should be easy to handle such kind of downtimes. So if you are completely designing your application in a synchronous manner, if one of the component goes down, everything else that depends on that particular service wouldn't be able to function. So one of the thing that we can do is doing asynchronous processing. So that's where event-driven architecture comes. It's like when anything happens, instead of, if at all possible, you can try it in a processing in a async fashion instead of making a sync calls. So that is where event-driven processing came in. But it's just the introductory part of it. Once we go into this event-driven architecture, there are lots of things and lots of practices, patterns to follow. But that is where it starts. You want to enable many subsystems still continue to function, even some of the services goes down. That's where event-driven architecture fits in.
Okay. Kaushik?
Yeah, I agree with what Shiva said. When something like this has a name, like event-driven architecture, it indicates it's a shift from what is normally done. The regular architecture versus this new thing, which is event-driven architecture. So the regular architecture, which which has been the norm for quite a while, is this request-response model, right? So two things need to communicate. One thing makes a request, the other thing responds. That works fine, but there is an alternative way to make things communicate, which is via events. A good analogy is a phone call versus messaging. Okay, so you want to communicate with somebody. One way to do it is a phone call, but then the phone call is a little problematic because you need to make sure that the other person is there to pick up the call. Your schedules have to align. All that stuff is like you have to make sure that that whole exchange works fine exactly at that time, right? As opposed to messaging, which is a little easier, right? You want to communicate something to somebody, you just send them a message, and then it's like, I don't have to know if that person is free, if that person is available right now to read the message. I'm just going to go ahead and send the message. The message is going to sit there. Whenever the other person is free, they're going to read it, and they might respond back with the message. So the asynchronous part of it. It's not request response anymore. This might still be request response, but it's not online. It's not happening at the same time, right? It's asynchronous. It's offline, and having systems interact in this asynchronous, message-driven model is what is commonly referred to as event-driven, as opposed to the request response that we've normally used to. There are a lot of obvious benefits to this. One is, of course, fault tolerance. Just like with the phone call, the other person doesn't have to be available at home. Like, you can send a message, the other person can come home or like get to their phone at any point and then respond back. It's fault tolerant. It's more reliable. And the other thing is also about managing data. We'll probably talk about this later in this discussion, but event-driven architectures has been a blessing, a boon in terms of handling transactions and data across multiple services, which the traditional request response model kind of fails. There has a lot of challenges which the event-driven architecture tries to address. So actually, because of those reasons, event-driven architecture has become quite popular lately to solve some of these problems, and also it's an alternative way to have services communicate. So that's event-driven architecture in a nutshell.
Okay, that's a great introduction to what event-driven is. Just like, I think one of the key things that we are talking about is asynchronous communication. But asynchronous communication, if I look at it, is nothing new. We have been doing asynchronous communication for a long while now. So, what is the need? I mean, what is it different? How is event-driven architecture different from typical asynchronous communication? And also, what are the technology drivers which are probably enabling event-driven architectures? Koushik, do you want to start?
Sure. So asynchronous communication is not anything new per se. So if you think about it, like if you're working in UI, pretty much everything you do is async. It's more of like responding to something that might happen in the future. It's not like a certain start and end. Let's say you're writing a batch system, right? So you have a certain start point, you do a bunch of processing, and then it ends, right? There is a fixed flow, branches of course, but the flow is fixed. But with UI, you really cannot do that. So what you're doing is you're kind of when something happens, you got to do something. When something else happens, you got to do something. So that kind of brings into the whole the reactive paradigm of writing code, right? So reactive and event-driven architectures kind of go well together, but they're not necessary. You can have the traditional batch systems do event-driven, and you can also have reactive systems not do event-driven. That part is a little difficult. So asynchronous in general has certain advantages. One is the UI example that I gave, where the domain itself requires asynchronicity, right? You don't have like a predictable flow, and things might happen at some point, and you have to handle that. The other advantage is to reduce complexity. One problem I've seen a lot of people have is when they adopt a microservice architecture, they break their application into smaller pieces, and they say, okay, they start out at least with, okay, this service communicates with this service, this to the other one. They have neat pictures, but then over time, that picture tends to get messy. Okay, so it's like this, all the services kind of communicating with everything else. If you draw arrows, like all services have arrows to everything else, because over time needs change and all that. So one way to handle the problem is to kind of rethink how you draw those boundaries and say, okay, now I want to kind of like move things around so that this isn't a mess. But again, that's a constant struggle, right? Or maybe there is a need for all these different services to talk to each other. So rather than have this kind of coupling between all these different services, which is difficult to manage, how about instead you have services send out events and say, hey, this thing happened, and then there are others which listen to the events rather than it being more of like a request response. So there was this concept of domain events that came up as a result, in the sense that if you do strict domain-driven design and then you have microservices based on different domains, um, two services need to know what's happening in the one service needs to know what's happening in the other service only when there is a significant event that happens there. So, for example, order and purchase. No, order and shipping, for example, right? So the order service sends an event saying, okay, an order was placed. And then the shipping service receives that event and then says, okay, I'm going to do stuff in order to make this order fulfilled, right? As opposed to the order service saying, okay, go shipping service, go do this thing. So that is a different way of looking at this problem, and it simplifies things radically, right? So an order service, when I'm writing an order service, I don't have to think about, okay, who do I have to tell, right? Who do I have to inform that this thing happened? Instead, all it does is send out an event. So it simplifies this whole maze of interactions, and it's easier to reason with as well, at least when you're building one service. The complexity is still there, but at an individual service level, it makes it easier. So I think that is kind of like the benefit of asynchronous and event-driven models.
Okay. So basically what you're talking about is the fact that if an order is placed, you just send out an event saying an order is placed, and whatever services need to react to that would be probably listening on that, and they would react.
Yeah.
Kind of like, so there is a separation of concerns. Instead of the main service being responsible for everything, it is now just responsible for probably just putting a message on the queue saying an order has been placed, and probably all the other things would be kind of byproducts of, I mean, our individual responsibilities of other services which are listening on to it.
Right, because separation of concerns is a good point that you mentioned there, because people tend to think that, okay, separation of concerns is you have one service which does this thing, another service which does something else. We have separated concerns, but there needs to be something that stitches them all together. And usually what used to happen was one service would invoke the other service, right? So that is, you're kind of violating the separation of concern there a little bit, because yes, you've got the functionality in two different services, but still one service needs to know that the other service exists. So there is a little bit of coupling that's still there. With event-driven architectures, you kind of break that away as well. So the order service just goes, hey, order placed, and whoever is listening, just do whatever you want with it. So it's like you completely separate concerns at that point. So that's a huge advantage.
Cool. Shiva?
Yeah. So, processing asynchronously is not new. We have been doing this for a long time, like using messaging queues. There are various types of message brokers, JMS technology, and all that. Usually, what we have done, we publish a message, something happened, and then there will be many other services which might be interested in that event. They listen and they read the payload, and then they process it, and then the message got removed. That's how usually the message processing was. But with event-driven architecture, it's a bit different. It is not just a message for one time. It's a log of events happen over the time, and any service who is interested in listening to that event and act accordingly, so the log won't get deleted. The events are going to be persisted, so that any new system that comes online, later built or something like that, if they want to replay all that events, those events are still there. You can start from scratch and then process all those events. So it maintains a log of all the interesting events happened over a period of time, instead of just publishing a message, processing it, and then getting it deleted. So this is how I see difference between simple asynchronous message processing versus event-driven architecture.
Okay, cool. Shiva, you were actually, like, when you answered this question previously, you were actually talking about the difference between one-to-one versus public subscribe, and like that also playing a key role in with respect to event-driven architectures. Do you want to elaborate on that?
Yeah, when we talk about point to point, usually using queues, somebody publish a message, and there can be one or more receivers, but only one of them get the message and then process it. Once the processing is done, the message got deleted. There won't be that message anymore. Similarly, if it is a pub sub, there can be many subscribers, and I am not sure once all the receivers got received whether that message is going to be deleted or not. But every receiver is going to get a message copy of it. But I don't think there is a provision where if a new subscriber system came in, can they receive those old events? I don't think so, but I have never verified that. But this event-driven architecture is different in that aspect, where you have that log of events, and any system, even suppose today you started this new service, but you want to consume events happened in the last 1 year. So those events are still there. They can read all those events, and then they can build up their knowledge base. So that's the difference between the traditional messaging systems versus event-driven.
Perfect. So what we are talking about here are a couple of advantages, right? We are talking about resilience, fault tolerance being one of the advantages. The other one we can see is the flexibility. At a later point in time, if you want to process the events again in a different order, I mean, again, if you made any mistakes, you can do that. You have the flexibility of doing that. Any other advantages you want to touch upon, Shiva?
Yeah. So when we think about event-driven architecture, right, there are usually, as Koushik already touched upon it. So you won't have system-to-system communication, direct communication, and also every consumer they can build their own knowledge base. Suppose one event happened. For example, let's take the same example of any e-commerce system. Let's say one order is placed. There can be one system who is interested, actually the order processing system, which has to receive that event and then process it. And there can be another system like analytics system. So they are interested in okay, who is the customer placed this order, from which region these orders are coming from, or for which kind of a products orders are coming from, because their interest is in understanding what kind of a products are selling more, or from which regions of the geography they are getting more orders. So the interest is different. So in this event-driven architecture, one system they can publish it, and then there will be in a large enterprise there will be more than one department who might be interested in these events, and then they act upon differently. In the same case, say there is inventory service. So they want to see, okay, they want to check minimum inventory levels to be maintained. So they are saying, okay, orders are placing for so and so product, and then they need to check, okay, do we have this kind of inventory levels, minimum inventory levels. So like that, there can be wide variety of consumers, and their interest of processing that event could be totally different. This enables in the large organization without having to have a point-to-point communication. There will be a central messaging server broker, and then there can be one or more consumers of it. It decouples all the systems, and they can grow independently without having to have a tight coupling.
Cool. So loose coupling is one more advantage that you are referring to in there. So Kaushik, any other things that you can think of?
I kind of alluded to this earlier. I think handling distributed transactions has been a very big plus for event-driven design. If not for designing the whole system as event-driven, perhaps having a mix of request response models and event-driven models, but having the event-driven part just take care of this messy problem of distributed transactions. It's not easy. You end up having a whole lot of, like, when you're tackling distributed transactions, you know upfront that it's not going to be easy. But then once you start implementing it, there are so many things that can go wrong. So event driven has a couple of good patterns for handling it, and that has been a reason for many people to think like, okay, let's do event driven only for this part of the architecture, just so that we can do distributed transactions well. So I think that's another plus for event driven.
Awesome.
In
Do you
fact,
want to elaborate? Go ahead, Shiva, please.
in fact, it is a suggested approach not to go full on event-driven for the entire system, and most of the times it is combination of request response and event-driven. And event-driven is limited to communication between one service to another service, and still have good portion of service dealing with the request response synchronous model. Um, going full on with event driven for the entire service, unless there is a good reason for it. It's complex and it is not suggested approach also. There will be a lot of complications.
Awesome, awesome. So it's when you have complex communication involving multiple systems, maybe that's where the complexities behind event-driven architecture are probably justified, right? So, Kaushik, I mean, you were touching upon the fact that distributed transactions are difficult, and also there are patterns in event-driven architectures which help with distributed transactions. Do you want to elaborate on that?
Sure. So this is a pretty big topic, but I'm going to kind of give like a very high level view of this. Um, so transactions are simple when you have one database, right? We've been doing that for years now. Have one database, the database is going to take care of it, right? You say start the transaction, do a bunch of inserts and updates, end the transaction, right? You have so many use cases for it. Monolith, single database, problem solved. No need to worry about. The problem happens when you have microservices or any distributed system where you need, first of all, in a well-designed microservice system, you have services with their own databases because you don't want to share database. That's a problem. You run into issues where you have coupling even though you have separate microservices because they're both reading the same database dependent on the same schema, whatever, right? So each microservice has its own database. But now the question is, how do you handle transactions? So let's say there is an order that needs to happen. I'm using the e-commerce example again. An order needs to happen. So what do you need to do? First, you need to make sure that the item is in stock. You need to charge the user's credit card and then make sure that the payment goes through, right? And you need to there are a bunch of other conditions that you need to check, right? Only when all those things happen, then the order is committed. Now, these things in the microservice architecture, they're not in the same database anymore, right? So the order has its order database, and you have the payment as its payment database, or maybe something else, right? So how do you do commits? How do you do transactions? One way to do it, of course, is to have like one coordinator where you say, okay, I'm going to start the transaction for each database and then do all the inserts and updates or whatever. Each microservice does all that stuff. And then you commit the transaction, and any one of them fails, you roll back everything else. Well, that's not efficient because now you have like most of these tables, once you do a transaction, you're kind of locking that table, right? You can't do anything else there. So you don't want to have one transaction and hold off on something else. This is again, one way to look at is you're basically restricted by the cap theorem. If the listeners don't know, cap theorem kind of it says that if you want consistency, you cannot have availability and partitioning, right? Distributed systems is partitioning, and you want availability with distributed systems. So A and P are taken care of, which means you have to give up on C, right? And now what we're trying to do with distributed transactions is try and get that C as well in addition to A and P, which is basically what the cap theorem says, like it cannot be done. So one way to kind of hack this and make sure you have some kind of consistency is to say, well, I'm not going to have one transaction anymore across all these different systems. What we do is somebody makes an order in this example. We send out an order message, right, on an order event. It's a domain event. And anybody else who's listening to it, go do their thing. And now the payment microservice is listening to this order event. It says, okay, now I need to do the payment thing. It goes and does it. The shipping microservice does the shipping, right? So it's independent. Now the question is, what happens if one of them fails? So when a failure happens, let's say payment microservice tries to make a charge the user's credit card and it fails. Guess what? With event-driven architectures, it doesn't roll back. Well, it rolls back its own database because it can, of course. But then it sends out another event. It says payment failed event, which is yet another event in this event-driven architecture. And guess what? All these other microservices are listening for payment failed event as well. Like an order microservice is going to listen for a payment failed event. And it's like, okay, has a payment failed event happened? Well, in that case, I'm going to have to roll back the order or cancel the order. Okay, so that's one way to ensure that you are eventually having a transaction of some sort, but you're not waiting for all the things to happen before you say commit. This is a common experience I see in a lot of e-commerce experiences that I've had, right? I make a purchase and for some reason I use a card which is expired or whatever, or doesn't have funds, or whatever reason, right? So my card is not linked properly or whatever. The order says it goes through, but then at a later point, I get an email saying, hey, your payment did not go through. So the order has been updated. Well, guess what's happening? It's basically the payment microservice sending an event and the order microservice responding to it. So this is possible because of event-driven architecture. Think about it. There's no way we could do it in request response. If you were to do it in request response, you have to have one request, somehow one request waiting for everything to go through. So this is one benefit of event-driven architecture. It makes distributed transactions manageable. Not quite transaction in the traditional sense, but you have a way of coordinating those things. Very complex topic. I've tried to simplify it and shorten it as best as I could. Hopefully that makes sense.
Yeah, I think you made it pretty simple to understand, Koushik, as usual. Shiva, I think one more advantage that we typically talk about when we do async or go to event-driven architecture is scalability, right? So we because it's no longer one request response cycle, and probably we are splitting the uh, like splitting the work into more distributed, distributed way. Scalability is something which might be impacted as well, right? So do you want to touch upon that?
Yeah, before that, just want to add something to what Koushik mentioned. So when we are designing our system with microservices and event-driven architecture, two-phase commit is kind of out of question because that is defeating the whole purpose of going with microservice architecture. If you have this two-phase commit protocol for distributed transactions, you are again limiting the whole. I want to independently be able to deploy my application. That is going to be defeated. So when we go with the microservices along with event-driven architecture, you lean towards eventual consistency rather than having transactional across services. You lean towards eventual consistency. So it's like a optimistic approach where you again taking the same example of taking the order you take, and you mostly go with the optimistic approach of everything is going to be fine, and then you acknowledge the customer saying that okay, we received your order, we are going to process it, and then you process it, and if there are any failures, eventually you let the customer know, but taking the percentage of success rate, you take a optimistic approach and proceed further to process it. And again here coming to the scalability, because we are offloading it and then leaning towards processing in an async fashion, it is kind of a scalable by nature. What I mean by that, you received a request and then maybe you persisted and then sent out an event. And then there are a bunch of consumers who are interested in that message who are going to get notified and then they can process it. So now, when we think about how we can make it scalable, one problem we already solved by removing this request response barrier. And then the next thing is you lean towards what kind of messaging server you are using, messaging broker you are using. So that depends your scalable factor. Like you are maybe using RabbitMQ or you are using Kafka. So how efficiently you use Kafka, how efficient your Kafka infrastructure is, that defines how scalable your overall system is. So yeah, by default you are removing that request response model. You are taking a request and then acknowledging the user customer, and then you are offloading it in an asynchronous fashion. So yeah, later the good your messaging infrastructure is, the more scalable it is.
Absolutely, absolutely. I think we have talked a lot about the advantages of event-driven architectures and how they compare with the request-driven architectures. And probably we'll take the discussion now towards some of the enablers of event-driven architectures, right? Why did we not do any event-driven architectures a few years back, and why are we doing it now, right? If you look at the evolution, I think one of the biggest evolutions has been Kafka, probably because it enabled the publish subscribe mechanism where I have multiple subscribers listening on a specific thing and reacting to it. And the other important factor you were touching upon earlier, Shiva, as well, is the replay capabilities, right? To be able to kind of think of it as an event store, kind of have all the events stored there and have the capability of replaying them as we go. So, Shiva, do you want to touch upon any other technology things which enable this? Why are we seeing in event-driven architectures now and not earlier?
Actually, I worked on a system almost 10 or 11 years ago, which are kind of depending on event-driven model. Back then, we called it as SEDA, staged event-driven architecture. So again, it was a big e-commerce system. Like it's huge. Like it's kind of a marketplace, and then there are vendors who put their catalog on the system, and then customers can place the order, and then order goes through a lot of process. So then we were using JBoss, and then there are almost 27 or 30 applications which takes care of doing one thing at a time. And then once their process is done, they send out a message to Oracle Advanced Queue or something, and then another service which picks up that message and process it. So it was not new, but there is a good reason why most of the applications don't go for event driven. It is not easy. So in theory, it looks like okay, I can publish an event and then let whatever people do take care of it. But again, for every event, there would be a event process, right? Let's again take the same example of order. Okay, you create an order and then you try to process it, like payment processing or whatnot. And what to do if it failed? You need to undo all these events, right? So in a typical request response model, you only implement this forward processing. When you go with event driven architecture, for every event processor, you need to implement a compensating failure rollback operation also. So you received an order and payment is successful. That's an event, payment successful. So that indicates many other systems to proceed further with that order. Whereas if it failed, in all other those services, they might want to have an undo implementation. So it's complex. It's not easy. The benefits are there, but again, it's complex. So considering all that, because recently we have, as you said, more powerful Kafka and things like that, it is becoming achievable. But earlier we do not have that much of a solid infrastructure in terms of messaging and all that. So yeah, because of these new capabilities, people are approaching it more and more. Um, Again, event-driven implementing event-driven architecture, it's more effort, more difficult, but if you can do it right, it has great advantages of scalability.
Cool. So, yeah, I think let's probably switch towards the challenges in implementing event-driven architectures. You were specifically mentioning some of them, like implementing transactions, like making sure that you have compensating transactions present, right? Are there any best patterns that people can follow? Are there any best practices around how you can do transactions with respect to event-driven processing?
Yeah, typically there are two approaches. One is, SAGA. It's called SAGA pattern, where there are two approaches. One is orchestration, and another is choreography. Where orchestration is like there will be one composite service which orchestrates the whole process. Like if it receives an event, it makes sure all these downstream calls are happening successfully. If any of the processing failed, it takes care of doing the compensating transactions. Whereas in choreography, there won't be any centralized authority who coordinates all this process. Where one originating system, they publish the event, and every other consumer they receive it and then process it. And again, as Koushik mentioned, if one event processing failed, so they again publish a failure event, and again all these services they also listen to that. So the difference will be having a centralized coordinator versus decentralized approach. With centralized approach, not every service need to be aware of how to do this, because there will be a central coordinator. Again, they will be initiating all that process. Whereas in decentralized approach, every system, they need to be aware of how to undo their process for event handling. Yeah, these are the two approaches most of the times people follow.
Okay. Koushik?
Yeah. Which question do I answer? The first one or the second one? So you talked about why event-driven is popular now, and the second one is about challenges that event-driven architectures solve.
Oh, probably we'll take the first one first and the next one after that.
So yeah, I think there are a bunch of things that's led to event-driven architectures being popular now. One is, of course, the technology capability. Kafka is a really good way for services to communicate. It's not just an event bus; it's also an event store. Right? It's kind of like a database for events, which is super helpful in terms of building reliable services. In addition to this, I also think there is a shift in the way we are using events, because we mentioned this earlier as well. Event-driven architectures are not new. Even before this event-driven microservices came about, there was this old concept called enterprise service bus, which was kind of an event-driven way of handling service-oriented architecture, SOA as it's called. So it has been around for a while, but I think what's different this time and what's led to its popularity is the event-driven architecture is more focused on solving business problems rather than solving technical problems. The whole enterprise service bus and SOA was very technical. It was about solving programming challenges. It was about making development faster. But here, when we're doing event-driven architectures, especially with microservices, we are thinking about problems like domain partitioning. It's kind of starts with domain. Everything we do starts with domain first. So I think that's a big shift in basically the way we think about events, and that's led to us making the right decisions for, or at least the way we think is right now. A few years from now, that might become wrong, but at least for now.
That's usual.
Yeah, that tends to happen. The industry changes, and that's normal. So right now, what we do is we say, okay, for us to adopt event-driven architecture, the reasoning behind it is to separate microservices, separate domains, and achieve independent deployability, independent, development, independent way of handling business changes and all that stuff, independent scalability, a whole lot of that stuff. So that is the focus for event-driven architectures today, and I think that is a big shift, and that's kind of solving real problems that we have with microservices. Distributed transaction is one thing, reliability is another thing, right? It's solving real problems. So the way to put it is, we are having technology benefit from building systems thinking about business first, right? So we are getting the technology benefits that SOA and ESBs had always promised but never delivered. But we're getting it even though we start with the business and the domain first. So I think that's a big win, and that's I think main reason why it's becoming so popular these days. Just my opinion.
Cool.
To answer your second question about the challenges that event-driven architecture solve, we touched upon a few of this already. Distributed transactions, distributed state is one thing. Decoupling is another thing. We get kind of complete decoupling, complete separation of concerns. We also have reliability, which is another thing, because of the way we can store events. Even if a service were to go down, it can come back up again and be like, okay, what did I miss? All the events are right there in the queue. It can kind of pick it up and process it afterwards as well. So I think those are some really good benefits of event-driven architecture.
Yep. So in terms of the patterns that we are talking about, we touched upon SAGA pattern, and we also touched upon event sourcing. Any thoughts on that, Koushik?
I think SAGA pattern is really interesting, and it works if it's done well. The two ways you can do it, like the orchestrator and the choreographer, right? So if you go the orchestrator route, what it basically means is you have one thing which is orchestrating everything. It's like, okay, you go do this thing. Oh, did you fail? Hey, you go roll back, right? So there is one central point of business logic also equals to one central point of failure, right? So what if
Sounds
that
like a
thing was
ESB.
exactly right? We are kind of going back to the ESB way of doing things. So that can be badly implemented. Okay. On the other hand, you have the choreographed thing where each service kind of fends for its own, right? It's like, okay, I'm going to do this, but I need to watch, has something else failed? If it has failed, I need to do the right thing. So that can work. But what I have observed is I've seen code bases where people do this, and it's hard to make head or tail out of it because each service is doing its own thing. Like if you want to look at a high level and like, okay, what on earth is going on over here? You have no idea, right? You in order to understand it, you have to go look at all those 10 different services, understand the business. There's no one place for business logic, so that has some disadvantages too. But I think it comes to any pattern. Like, see, this is a pattern to handle complexity and make it easier. It's not going to remove complexity. I wish there was a magic pattern like that, but it kind of makes things simpler, but the complexity is still there. You have to handle it somehow. Event sourcing is I would hesitate to recommend it because it's, we talked about event driven architectures being tricky. So event sourcing is like that trickiness dialed up to, I don't know, 11 now, right? Because it's should I explain what event sourcing is, because we haven't covered it so far?
Yeah, please.
I can explain. Yeah, I don't want to take too much of. I don't want to have too much of the time. But yeah, event sourcing is it's a very interesting concept, and I like it. The nerdy part of me loves it. So here is the idea, right? Why do we have problems with distributed transactions in distributed systems? Because we have single places for the source of truth, right? You have one order table, and all the orders need to go sit in that order table, right? We have one purchase table, all the purchases need to go sit there. So which means that if something were to fail, well, you got to go do that one table, that one record, and go update that, right? So it's like you have one place where that happens. So with event sourcing, the idea is, don't do that. Don't put one place where the data exists. You can do it, but that's separate from event sourcing. You can do a combination of event sourcing and the traditional way of handling data. But basically, the idea is you have a list of all the events that have happened, right? This person bought this thing on this particular time. This event, the purchase event was made. This event was made. So there's a list of all the events available in a Kafka topic sitting there somewhere. So if you want to know what happened at the end of the day, you just go look at those events. Just go look one by one what happened. Pick all the items. Like, you want to know if a certain user's order went through, look at all the events for that user, and you can figure out at the end of the day, did it go through or not? So in this particular case, there'll probably be one event for the order, one event for shipping, one event for purchase, one event for purchase failure. So what ended up happening? So there was a failure in purchase. So it didn't go through. So if the purchase had gone through, there would have been one purchase successful event. So at the end of the day, you can infer, okay, the purchase went through. So what you have here is basically data sourced not from a database, but from a series of events, which is basically what event sourcing is. The plus side, you don't have to worry about transactions. Everybody just publishes events. It just goes, sits in a queue. But the negative is, of course, there's no one place to look it up. If you need to know what happened to a certain thing, you got to go look at 10 events, scan through the whole event queue to figure that out. So that's event sourcing. As you can imagine, it's a very radical shift in the way we store data. And you have to be really, really careful if you adopt that model. I know people who adopt that model, but still at the end of the day, they kind of compact all those events and save it to a database. Like, okay, so much events I've stored, let's compress all those, save to a database, and then let the next batch of events gather and then periodically persist to a database. It's a combination. So yeah, be very careful if you're adopting event sourcing. It's not easy at all.
So if I understand it right, rather than database being the source of truth, now the event store or wherever you're having this set of events becomes the source of truth. Shiva, thoughts?
Yeah, event sourcing has a specific. It fits only a specific set of needs. it shouldn't be just adopted just for the sake of, okay, let's go and use event sourcing. It sounds good. Because as Koushik mentioned, yeah, you have a log of all the changes that happen to a particular entity, but at the end of the day, customer wants to see what is my data currently, how it looks like. So when do you do that aggregation of all that compaction? When do you do that? So again, having that log just alone doesn't fulfill. So that's a kind of a byproduct. Suppose you have a specific requirement where maybe you have some auditing requirements to strictly have what happened over the time, who made the change. So all that kind of a need. So then event sourcing might help. If you don't have such need, okay, nobody cares about the history. All they care about what is the present snapshot of information. Then that event sourcing adds a lot of complexity to deal with. So yeah, event sourcing limit to specific needs, but I wouldn't recommend to adopt it as a general preferred approach.
Cool. One more challenge when it comes to like messaging in general is idempotency, right? There is every chance that you might receive a duplicate message. Um, like so, and in event sourcing, we are talking about that multiplied by maybe 100 or even exponential growth, right? So, how do you handle idempotency? Is that a challenge that you see, or are there any specific techniques that you use to handle idempotency? Either Shiva or Kaushik.
Yeah, idempotency again, it depends on what kind of events you are dealing with. Some events are like it just overwrites the information as it is a current snapshot of data. So it doesn't matter how many times you receive. So duplicate event receiving is fine, but many events they are not. It shouldn't receive multiple times the same event. So some way is like how do you define a unique key for that event? Maybe it's kind of a tagging with so and so event with so and so UID, GUID. So based on the combination, maybe you need to identify whether it is a fresh message or is it a duplicated message. And again, depending on the technology you are adopting, like Kafka or AWS SQS, there are some techniques to tune so that you receive exactly once. Yeah, you need to handle based on the technology you are using. And sometimes it is okay to receive duplicate events and then you just override that information. But sometimes you need to make sure you are receiving only exactly one semantics. Uh, yeah.
Cool. Kaushik?
Yeah, no, I agree. I think the best way to handle it is have a good ID generation mechanism at the source of the events, so that you're not like duplicate events usually happen beyond the event sending mechanism, because if there is some kind of let's say the whole thing which triggers it is like a front end sends out a request, it's still request response. That happens only once. So I think the weak point is when a service sends out an event to the event infrastructure. Depending on what the event infrastructure is, you might end up getting more. So it's just about enriching that event payload with some unique ID, so that even if that were to happen twice, two events sitting there, it'll have the same unique ID. So whoever is consuming it can ignore it based on what's happening. So you kind of have to deal with that. I think there are certain eventing technologies which do it for you. So for example, if you were to declare a certain field in your event payload as an ID, it can handle that automatically for you, so you don't have to do it. But I don't have much details about that. There must be some way to kind of prune that out. So that would be the recommended way, because really there's no way to separate that out beyond that, right? So your event sending has to be with that extra information.
Perfect.
Also,
Perfect.
not only while sending the message, sometimes even if sender sends only one message, while processing, there is a chance that you may receive duplicate events, especially in the case of AWS SQS. If you fail to process before that visible timeout happens, another service might receive the same copy of SQS event. So
Yeah.
yeah, you need to be cautious both while sending and then receiving. You need to have this processing capability, whether you want to process it only once or is it okay to process multiple times.
Is that for when a service is trying to remove an event from the queue, or is that even for read? The read can be duplicated.
Uh,
It's
are you
actually for,
asking for?
as far as SQS is concerned, there is no guarantee that a message will be delivered only once. So
Okay.
the guarantee is
That's a
at least
problem.
once
Yeah.
delivery. It's not a only once delivery, and
Okay.
that's where the guarantees. Like I think that's challenge with most of the messaging services. Most of the messaging services guarantee you at least once thing, right? So they don't guarantee you it will be delivered just once. There is a chance that duplication happens, and that's where I think the whole conversation around idempotency, especially in the case of async communication, becomes really important. Cool. Like I think as we go towards async, uh, is there a preferred language to develop these applications in, right? So if let's say there is a enterprise which is using Java typically, right? Are there other languages that we suggest when they are going for event-driven architectures, or can they continue with using Java, for example?
So I think it should be language independent and depends on what is the messaging broker you are using, and also the payload requests should be independent of the language. Otherwise, you are making an assumption of okay, all these clients they are using so and so technology. That's going to break this loose coupling, right? You are making an assumption of the consumer language and all frameworks, things like that. So, based on what I see, so far, most of the times it relies upon JSON format, and
Okay.
any platform can handle it.
Okay. I mean, the reason I was asking is when actually I was looking about event-driven architecture, somehow I had a feeling that there's a preference for Go language because it is better at handling concurrency. But I mean, it's just some random thought based on what I read. I just wanted to see if it's what you see in practice.
No, Go language concurrency is better, but it has nothing to do with event processing. Any language is equally capable of processing.
Awesome. So we talked about, okay, what is event-driven architecture, how it is different from request-driven architectures, and what are the right use cases for using it. And also we discussed about the challenges with respect to event-driven architectures.
One of the
Any
challenge, few one challenge that I would like to mention is um, these systems grow over the time and there will be changes, right? Like today we might send a message in so and so format, but over the time you may need to add more fields or you may need to change the fields. So how do you communicate this across the board? Like they might assume that they are going to receive so and so payload with having so and so fields, but that might change. So a lot of caution needs to take while enhancing your event format. Most of the times you need to be backward compatible. Even if you are changing a field, most likely you might change in addition to sending the old field, you may need to include the new field also. So like that, there are some standards like RO or something like that in case of Kafka. So definitely, it should be carefully. We need to evolve this in a backward compatible manner. Otherwise, you are going to break a lot of clients, which you don't even aware of. Whoever is consuming your events, you have no idea. So it should evolve in a backward compatible manner.
Absolutely. Any other things that you want to touch upon, Shiva?
Mm, That's
Okay. Kaushik, any other things that you want to talk about?
Now, I would just say that this is just one way to handle problems, and there are specific problems that event-driven architectures handle. I think we've mentioned this enough times already, but you can't just adopt this as just any other alternative to as an architecture, right? So if you have those problems, only then go with an event-driven architecture. Because as with just as with microservices itself, you adopt microservices, you solve problems, but then you pay certain costs. The same thing applies for event-driven as well. You solve problems, but you pay a certain cost. So make sure your cost is worth it. If you're not having the problems that these event-driven architectures solve, don't even go for it. It's good to learn and know about it, but choose wisely is what I would leave the audience with.
Yeah, as we all talk about, architecture is about making choices, and making choices need trade-offs. And there is no one silver bullet which works all the time. It's about being aware about all the things which are happening and making the right choice based on the use case or based on the problem that you are solving. Very interesting thoughts there, Koushik and Shiva. Thanks a lot for joining me today. And for the viewers, if you have any other topics that you would want us to discuss, do post them in the comments, and I'll discuss with Koushik and Shiva and see if we can actually bring them on as topics for future conversations. Thanks a lot, Koushik. Thanks a lot, Shiva. Thanks for taking the time and being available here.
Thank you.
Thank you.
Do not forget to subscribe. Go ahead. I'm waiting. Thank you. Keep learning every day. Keep learning in 28 minutes.